So topic 14 is going to cover some classic applications of quadratic functions. In topic 13 we looked at all of the mechanical things that you can do to quadratic functions, and now what we're going to do is apply those to application problems where the key features of the function will be interpretable, and then we'll hopefully round everything out by doing a quadratic model for a real data set. So in video 1 we're going to look at analyzing a quadratic profit function, and we're going to do everything that we possibly can do with this profit function. So we're told that the cost to produce bottled water is modeled by cost as a function of n equals 16n minus 63, where n represents the thousands of bottles produced. So for example, if n is equal to 2, that means 2,000 bottles have been produced. And then we're told that the income or revenue from selling those bottles can be modeled by the revenue function, negative n squared plus 326n minus 7,463. So the general idea here is that your profit is going to equal the revenue that you generate by selling the item minus your cost to do business. So you have money coming in, but you're also spending money. So our profit model is going to be profit is equal to revenue. Revenue represents the money that you earn, negative n squared plus 326n minus 7463, and it's going to be minus parentheses minus the cost to do business, and the cost to do business is modeled right here. So minus 16n minus 63, and this is going to equal negative n squared plus 326n minus 7463. Now we need to distribute this minus into the parentheses, so we're going to get minus 16n, and minus is going to be plus a 63. And then we want to simplify by combining like terms, so we're going to do negative n squared, and then we're going to take the plus 326n and subtract 16n from that, which is going to give us plus 310n. And then we have to take the minus 7463 and add 63 to that. And if we do that, we're going to get minus 7400. So this is our profit model, the model that tells us how much money we expect to make if we know the number of bottles that we've sold. So now once we have the profit model, we can do things with it. So for example, we could write this profit function or profit model in vertex form, which would allow us to find the vertex, and when we find the vertex we're going to go ahead and interpret the vertex. This is an application problem, so now the vertex is going to have an interpretation that goes with it, and there's more than one way that we can find the vertex. We're going to do it two different ways. This first way, we're going to find the vertex by putting the profit model into vertex form. So we have profit as a function of the number of bottles that we sold is equal to negative n squared plus 310n minus 7400. And then to put it in vertex form, the way that we did vertex form in topic 13 was we isolated the terms that had the n's, and then we are going to complete the square on the terms that have the variable, the input variable. And we want to recognize that to complete the square, the coefficient on the n squared term needs to be a 1. Right now it's a negative 1. So I'm going to factor a negative off of the minus n squared plus 310n. That's going to leave me with an n squared inside parentheses. And now instead of plus 310n, it's going to be minus 310n. Again, the way that we could check our work is distribute the minus into the parentheses and make sure we get back what we had on the previous line. Now I'm going to leave some space for completing the square, and I'm going to subtract my 7,400. So to complete the square, remember what we do is we take the coefficient on the linear term, take that coefficient on the linear term, we divide it by 2, and then we square it. So this is going to equal negative 310 divided by 2 is going to be negative 155, and we'll be squaring that, and if we square it, we're going to get 24,025 once it's been squared. So we take the squaring and we add it on the inside of the parentheses. We've completed the square inside of the parentheses, and now I need to make an adjustment out here so that I'm effectively adding 0 to the function. So I want to recognize that I have to pay attention to the negative sign. I haven't really added 24,025 to the function. I have distribute the minus sign in. Negative times positive is negative. I've subtracted 24,025 from the function as a whole. So I'm going to add on the same amount so that it cancels with the amount that I subtracted. So we wind up getting negative 24,025 plus 24,025 is 0. We've added nothing to the function. Now I'm going to take and recognize that I've completed the square on the inside of the parentheses. So it's going to be n, and then I have to identify what did I square. I squared a minus 155 to complete the square. And then I need to combine the minus 7,400 plus 24,025, and if we add those together, we're going to get 16,625. We just combine those using a calculator, for example. And now I should have enough information to find the model vertex, because we know that this is a squaring function, so the parent function is just the squaring function, and the vertex, because we want to find the vertex and interpret it, the vertex of the parent function or toolbox function, the vertex is at 0, 0. And once we're in vertex form, we can see how the original vertex has been transformed. We're subtracting 155 from the input variable, so this is going to move the graph 155 units horizontally to the right. So this 0 right here is going to get moved to the right 155 units. And we have a vertical shift of 16,625, so this 0, the output 0, is going to get moved up 16,625 units. So this is the vertex of the profit function. And technically, that vertex, the numbers inside the vertex, the ordered pair, they have units. This is not just 155. This is 155,000 bottles sold to generate a profit of 16,625. And I have a negation on my profit function. So this tells me this is not only a parabola, it's a parabola opening downwards, because this negation on the n squared has reflected the parabola over the x-axis. In fact, if we take a look at this function, we go ahead and take a look at this function. I'm going to keep that. I have it graphed in GeoGebra right now. Here's the function. I have my profit function. The horizontal axis is my N, or my bottled waters. I have the typical key features that you have on a quadratic function, right? I have a vertical intercept. I have 2 horizontal or N intercepts. And here I have the vertex. And because this parabola is opening downwards, this is actually identifying to me my maximum profit that I can make. This is right, this 155,000 right here says, hey, if I sell 155,000 bottles of water, I'm going to make a maximum profit of $16,625. Maximum because this is as high as you can get on this profit function. Every other place on the profit function is lower than the vertex in this case. So my interpretation the part where I interpret the vertex, I'm recognizing that I have that parabola opening down, which tells me that this vertex is at a maximum. This is the maximum point on the graph. So my interpretation is, if the company produces 155,000 bottles of water, they will maximize their profit based on this model. Their profit at the maximized profit will be, that's a horrible dollar sign. Even I can't handle it. The maximum profit's going to be $16,625. So that's the interpretation of that vertex. So this is finding the vertex by putting the quadratic function into vertex form, but we could also find the vertex another way. We could find the vertex, if we wanted to, by using the quadratic equation. So remember, the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. But in topic 13, we identified that the negative b over 2a component of the quadratic function gives us the x-coordinate or input coordinate of the vertex. So in this case, it wouldn't be x equals, because we're not using x as our input variable, we're using n as our input variable. So we would actually have n equals right there. Now, that tells us that the equation of the line of symmetry for our parabola is given by n equals negative b over 2a, again, from topic 13. So to find the n coordinate of the vertex, I just have to evaluate negative b over 2a. So I look up at my model and I say, what does a equal? Well, a is the coefficient on the squared term, so a is negative 1. And b is the coefficient on the n term, so b is just equal to 310. So the n coordinate of the vertex is going to be the opposite of b, but b is 310, divided by 2 times the opposite of a, or sorry, no, 2 times a, but a is negative 1, so we wind up getting a negative divided by a negative is a positive. 310 over 2 gives us a 155, which matches with the 155 that we got right here as the n coordinate of the vertex. And then to get the p coordinate of the vertex, because usually you have input x, output y, but in this contextual model we have input n, output p, so we have an n coordinate of the vertex and a p coordinate of the vertex. To get the p coordinate of the vertex, we evaluate the profit function by putting the 155 in for n and simplifying. So the profit at 155,000 bottles of water is going to be negative 155 quantity squared plus 310 times 155 minus the 7,400. So this is going to be negative 155 squared is 24,025 plus 310 times the 155 is going to be 48,050, and we're subtracting off the 7,400, and if we crunch this in a calculator, we're going to get $16,625, which matches what we got by completing the square and putting the function into vertex form. So we could have easily gotten the vertex this way as well. Again, the vertex is an ordered pair, so it's 155,000, K represents 1,000, 155,000 bottles of H2O, I believe. Yes, it's bottled water. and a profit of $16,625. So that would have been another way to get the vertex. Find the p-intercept and interpret it. So again, if we go and peek, if we peek at the graph of the function, this is the profit axis. This is the bottled water axis, the number of bottles axis. So the p-intercept is going to be the place where the graph crosses the p-axis, or the vertical axis. So when we cross the p-axis, we see that the input variable has to be 0 bottles of water produced. So if I go back to our playground here, to find the p-intercept, we want to note that the p-intercept happens, or that vertical intercept happens, when n equals 0. So we just plug 0 into the function. The profit when we sell nothing is equal to negative 0 squared plus 310 times 0 minus 7,400, which is just going to give us 0 plus 0 minus 7,400, or just negative 7,400. So the p-intercept is the ordered pair given by 0 bottles produced and sold, corresponds to a profit of negative $7,400. And my interpretation of that, see, it says interpret, which means write a complete sentence using good grammar preferably. My interpretation is that if the company produces and sells no bottles, they will lose $7,400. And this makes sense. If you don't produce and sell anything, you still have business expenses. You're going to lose money if you don't produce. It's probably what's happening to a lot of people right now during the pandemic, right? A lot of businesses are struggling because they're not being allowed to produce, but they still have expenses to cover. So there's the p-intercept interpreted in the context of the model. And we can find the n-intercepts and interpret them in the context of the model. So the n-intercepts, let's keep stuff. My n-intercepts on my graph are going to correspond to these 2 points right here. Where is the graph crossing the n-axis? And the key is that as we cross the n-axis, the output or profit is $0. So the profit is 0 as we cross the n-axis. And the n-intercepts in this type of problem where it's a profit model, these are called the break-even points, the place where you don't lose money, but you also don't make any money. These are the break-even points on the model. And what you would hope realistically is that a person would strive to exceed this break-even point by selling enough bottles of water, and that they wouldn't produce more bottles than they needed to maximize their profit. So you would hope that they would never get into this part of the model over here. So going back to the playground, find the n-intercepts. So to find the n-intercepts, I simply set p equal to 0. So I say, when will the profit be 0? What is the value of values? What are the values of n that will generate a profit of 0? So 0 equals negative n squared plus 310n minus 7,400. And I have choices now. I can use the quadratic formula to solve this. Right? If I have 0 equal to a quadratic equation, I can use the quadratic formula. Or alternatively, I can complete the square, which of course is, as always, everybody's favorite way to do it. Everyone loves to complete the square. So you can guess that I'm going to probably complete the square because I know that people know how to do the quadratic formula. So to complete the square, I'm going to look at this and I'm going to say, to use the completing the square technique, I know that the leading coefficient on the n squared term has to be a positive 1. So I'm going to take the right hand side of the equation and multiply it by a negative 1. So I get a negative times a negative is a positive 1. I'm multiplying both sides of the equation times the negative 1. Negative 1 times 0 is still 0. Negative 1 times negative n squared is just positive n squared. Negative times positive is minus 310n. Negative times negative is positive 7400. When we complete the square, we only need to play with the n squared in the n terms. So I'm going to subtract 7400 from both sides to get it out of my hair. And that's going to leave me with n squared minus 310n. And then we know that to complete the square, we take half of the linear coefficient. So we take the negative 310 and we have it, and then we square it, which is going to just equal negative 155 squared. We actually already calculated this. So negative 155 squared is going to give us 24,025. And we're going to take that amount and we're going to add it to the n terms to complete the square. And because I did it on the right hand side, I'm going to do the same thing over on the left hand side. So plus 24,025. So on the right hand side, by adding the 24,025, I completed the square. Whose square did I complete? Well, I squared the negative 155. That is the thing that I squared to get this term here. And then when I combine these two terms together, I get 16,625. And now I need to solve for n. So I'm going to take the square root of both sides. But when I take the square root of the constant, I'm going to go plus or minus. I'm going to go the square root of this. These will cancel. That leaves me with n minus 155 equals plus or minus the square root of 16,625. And then I'm going to add the 155 to both sides to get the n by itself. So I'm going to have 155 plus or minus the square root of 16,625. And I can approximate these. So if I do 155 minus the square root, I get, what did that come out to be? That came out to be about 26. It came out to be about 20. Struggling with my pen here. Came out to be about 26.06 when I calculated it. And then I did 155 plus the square root, which came out to be about 283.9. And this is approximately the n values. So if I look back at the graph, I'm going to keep those. If I look back at the graph, right here I see the 26.06, and over here I see 283.94. So that matches, the graphical evidence matches my algebraic evidence. So the intercepts are ordered pairs, so I'm going to put these into an ordered pair form. I'm going to recognize I can't sell partial bottles, so I'm going to go ahead and just round them to the nearest bottle. So I'm going to say the first intercept is telling me that if I sell 26,000 bottles, my profit will be $0. I broke even. I haven't made money. I haven't lost money. And my other intercept is telling me that if I sell 284,000 bottles, I will also make $0. And my interpretation would be to break even or have a profit of $0. The company needs to sell 26,000 or 284,000 bottles of water. Again, what I said earlier was, yes, these are both break-even points, but what you would hope, based on the graphical evidence, you would hope that this company would strive to get to this break-even point so they aren't losing money, but that they wouldn't produce more than the 155,000 bottles that gets them to this Vertex where the maximum profit is at. So you would hope that this break-even point or intercept over here is kind of a stupid place to be. This would correspond to overproducing. You see this like at Christmas time. A company like Walmart will have overpurchased a particular Christmas product and it winds up on clearance and they sell it at 75% off or 90% off. They had too much. Okay, so the last thing that we can do is identify a reasonable domain and range for the contextual model. In other words, what is a contextual domain and range? And this is something that we've dealt with in the past, but we're going to go ahead and deal with it again. So the idea would be the intercepts and vertices, the vertex, the two n-intercepts, the p-intercepts. These are all key things to think about when you're trying to identify domain and range of a contextual model. So the first thing I would say is it's definitely possible to sell no bottles. Hey, a pandemic hits and I produce and sell no bottles. That's possible. So I'm going to say n for my domain. I'm going to say that a realistic value of n would be, hey, n could start at not selling anything. N is going to be 0 bottles. And we talked about a little bit ago that here's your break-even point. And you probably wouldn't want to wind up at the other break-even point if you knew that a certain level of production was going to maximize your profit. So let's assume, as we make our contextual domain, that the company has modeled the number of bottles they need to produce to maximize profit, and that they're not going to overproduce. So let's assume, again, there's some assumptions that go into this, and they could be right, they could be wrong. So we could argue about whether this is a good choice or not, and that would be okay. But I'm going to say, hey, the company knows how many bottles they need to make to maximize profit. They're not going to exceed that amount. And once I do that, then I can identify my range. What's my range? Well, my range is the profit I can make. And where will my profit live? Well, if they sell no bottles, right here, if they sell 0 bottles, we see that they lose $7,400. So that's the worst case scenario. Best case scenario is they produce and sell 155,000 bottles. And if they do that, they're going to get a maximum profit right here, $16,665. So there's my contextual domain and range for my profit model.